Let's do these multi-step conversions. If you haven't downloaded the accompanying blank worksheet, you ought to do so, and you ought to have your calculator at hand and do these calculations along with me. Once again, we're going to be using the factor label method or dimensional analysis. The first one is convert days to seconds. If you know a single step conversion, a single conversion factor, how many seconds there are in a day, you can do that. But I don't carry that little bit of information around in my head. So we want days, we want to wind up with seconds. So we're going to put an intermediate step in here, going from days to hours, hours to minutes, and minutes to seconds. Remember the SI abbreviation for second is just simply an S. So 4.7 days. We want to convert from days to hours. So days goes in the denominator, hours in the numerator. There are 24 hours in a day. Now we want to cancel hours, go to minutes, and there are 60 minutes in 1 hour. And then we'll go from minutes to seconds, and there's 60 seconds in a minute. Days divided by days cancels. Hours divided by hours cancels. Minutes divided by minutes cancels. That leaves us with units of seconds. And if I do that on my calculator, 4.7 times 24 times 60 times 60, I get 40680 seconds. We're going from days to seconds, so that ought to be, the answer ought to be a very large number, and that certainly is. We've got the correct units, which is seconds. We also have to have the right number of significant figures. And we're taking this 4.7 to be a measured quantity. And so if we start out with 2 sig figs, we can only wind up with 2 sig figs. So the correct answer will be 41000 seconds. We don't truncate, we just don't drop those digits. We're going around the 6. We're going to take the 6 around the 0 to 1 and use those zeros to hold the place. Or alternatively, you could write 4.1 times 10 to the 1, 2, 3, 4, 5 seconds. Either one of those is okay. Writing in scientific notation certainly is more efficient. 2 sig figs, a big number, correct units. The next one. Let's convert 801 millimeters to nanometers. Millimeters to nanometers. We're using length, measuring length. I don't know a direct conversion factor between millimeters and nanometers. So I'm going to take millimeters, change it to meters, then meters, and convert that to nanometers. So this is, instead of being a 3-step process like the previous question, this is just going to be a 2-step process. So I got 801 millimeters. I want to cancel out millimeters. That needs to go in the denominator. Meters needs to go in the numerator. And milli is the SI prefix, which means 10 to the minus 3. So that goes in the numerator. Now I want to cancel meters, get that to nanometers. Nano is the SI prefix, that means 10 to the minus 9th. So 801 times 1 times 10 to the change sign 3 exponent divided by 1 exponent change sign 9 gives me 8.01 times 10 to the 8th nanometers. We've got the correct unit. We've got 3 significant figures. And we know that nano is a very, very small unit. And compared to millimeters, it's going to take lots of nanometers to equal a millimeter. So we ought to wind up with a large number. And we have 8.01 times 10 to the 8th nanometers. Now let's convert 63 kilograms to milligrams. And in a like manner, we're going to go through the single unit as a conversion, intermediate conversion. Go from kilograms to meters, then meters to milligrams. Because I don't know, I haven't memorized a direct conversion between kilograms and milligrams. So 63 kilograms. In order to get that to cancel, we'll need kilograms in the denominator. That will mean grams goes in the numerator. Kilo is a prefix that means 1,000. So the 1,000 goes with the grams. It doesn't go with the kilogram, because that conversion factor needs to be an equivalence, an identity. Now we're going to cancel out grams and go to milligrams. Milli is the SI unit or prefix that means 10 to the minus 3. So that will be how we will set up the problem. 63 times 1,000 divided by 1 times 10 to the minus 3 is 6.3 times 10 to the 7th milligrams. We want to use some milligrams. We got milligrams. We got 2 sig figs. We start out with 2 sig figs. And a milligram is a very small quantity compared to kilograms, so that ought to be a large number of milligrams in our answer, and we certainly have that. Remember, these definitions of 1,000 grams per kilogram and 1 milligram is the same as 10 to the minus 3 grams. They're definitions. They don't affect the number of significant figures. So since we started out with 2 sig figs, we're going to wind up with 2 sig figs. So now our last conversion factor involves volume. We're going to be using milliliters to deciliters. So milliliters, we're going to change to the singular unit of liter. Then we'll go to deciliter. So 24.57 milliliters. We want liters in the numerator, milliliters in the denominator. Milli is the SI prefix that means 10 to the minus 3. That's our first conversion factor, and it's a definition. Our next conversion factor is going to take liters, change it to deciliters. Deci is a prefix that means 10 to the minus 1. So 24.57 times 10 to the minus 3 divided by 10 to the minus 1 is going to give us 0.2457 deciliters. 0.2457 deciliters. Milliliters divided by milliliters cancels. Liters to cancel liters. That left us with deciliters. 4 significant figures. 4 significant figures. And a milliliter is smaller than a deciliter, so that means we ought to wind up with a number that's smaller than what we started out with, and so the 0.2457 gives us a good ballpark estimation of that. If we come up with 2,457, hopefully we would recognize that we've done something wrong. I think it's very important that we use conversion factors like this. Some people will use some sort of mnemonic I've seen on tests where they write out these letters that are the prefixes of going from nano to micro, millicenti, decikilla, mega, giga, tera, and as they try to move the decimal point around and get to the right prefix. And so oftentimes I see students do that and they come up with the wrong answer. They truly don't understand what they're doing. Whereas I think if you go back, use this factor label method, you're far better off and you'll come up with the right answer, as opposed to oftentimes coming up with the wrong answer using this method. So I would forget that method if you've learned it and use my method. Oftentimes I'll say, I don't care what method you use as long as you get it right. And that's true here. But once again, so often I see students come up with a wrong answer by many orders of magnitude by using this mnemonic method.